Okay, this section we're just going to kind of review Venn diagrams, reading Venn diagrams, back to our tree diagrams. Not so much probability, just as more about being able to just analyze data. We can set it up, a few of them with probability, but most of this is just how do we interpret Venn diagrams and tree diagrams. So first of all, a couple of symbols to remember. This symbol right here, this U, that means that's your union symbol. Kind of means or. And then upside down U, that's your intersection symbol. And that is kind of meaning the word and. Okay, so then we also have this, we do this a lot in probability where they'll say, or just in statistics, and it doesn't even have to be probability, but in statistics where they'll say not A, meaning, so if they're like talking about B, sometimes they'll say, okay, well that's not A. So that little apostrophe kind of is read, this is read as not A. So if you were only comparing two things, A and B, if I wrote not A, that would mean I was talking about B. So that's a new symbol to worry about. I think that's about it to help us with these drawings right here. So in this one right here, when we're talking about the shaded region, we've got circle A and circle B. They're both shaded. So that would be considered A union B. It's either in circle A or it's in circle B. Okay, the second one over here, it looks like to me that it's circle B is mostly shaded, but we're taking out a little bit of A. This piece right here got taken out, this part that's overlapping with A. So you could do that as B minus A. You could also write it as not A, because remember, not A would mean B, but in our Venn diagram case, it would also mean everything outside of, because when you're working with a Venn diagram, you have stuff outside here too. So not A, if you just wrote not A, that would mean everything outside plus this part in B. And that's not really what we wanted. We just wanted the part in B. So we're going to have to say not A intersection with B. So it's just the part that goes with the B. So you could do either one. I think B minus A is probably a little bit easier. Over here, circle A is just all shaded, so that answer is A. What region is circled for this one? Just B. Down here, we have the intersection. It's the places where A and B overlap, so we're going to say A intersection B. And then our last region looks like it's not quite all of circle A. So it's mostly circle A minus a little bit of B, right? Or we could say it's not B intersecting with A. All right. So that kind of just gets you thinking about how Venn diagrams, the overlapping area works, how we're going to do that. Okay, here's a picture. We've got choir and band, and then in the middle here, this would be choir and band both. And outside would be not choir and band. So I don't know what that means. Maybe that means everything else. I don't know. But that's the not choir and band people are on the outside. So how many students were surveyed? So you'll have to go through and add up 350 plus 50. So what do we got? 350 plus 50 plus 225 plus 375. Add them all up and you should get 1,000. Okay, what were the students asked? I don't know. You could something of, are you enrolled in band or choir or both? Are you enrolled in band, choir, or both. How many students are in both choir and band? Well, that was 50. How many students are not in either choir or band? That was 375. And then what is the probability that a randomly selected student would be in band? So remember, you're going to want to have total, so that's 1,000 students. And how many of them are in band? Now you have to do the whole circle, not just the 225 by the word band, but the whole circle, so 225 plus 50, so that's 275. So 0.275 or 27.5%. Okay, next one. So this one has 3 overlapping circles. So what does the 95 in the center tell you? Well, that would tell you those are all the people who take music, art, and foreign language. It's all of them, right? What does the 145 tell us? Well, 145 is right here. So what does that overlap with? Looks like it's overlapping with just here's the music circle. And here's the art circle. So I feel like that we're overlapping music and art. So those are the people who are taking both music and art. Okay, how many total students are represented in the diagram? So once again, we'd have to add them all up. And if you add them all up, you end up with 1,325. So which elective class has the least number of students enrolled? Well, you'd have to first of all figure out how many people are in music. So to do that, you would just come over here and add up all the numbers in the music circle. Okay, add all those up and you'll end up with 815. Okay, then I would check and see foreign language. So then we'll start over and we'll add up all the numbers of the students in the foreign language. So that's this whole circle. You have to add up all those numbers. And if you do that, that's 530. And then last, I would add up everything that's in the art circle. So come over here, add all the numbers in the art circle. So art's this circle. Add all those up and you end up with 520. So that means art has the least number of students enrolled in it. Okay. One more here. Let's see what we've got here. Okay, here's our diagram. It says 9th and 10th graders were surveyed during lunch. They were asked what grade they are in, as well as if they prefer pizza or hamburgers. A Venn diagram has been created. Label what each number represents. Okay, always start in the middle of your Venn diagram. If you'll do that, then everything else turns out to be correct. If you don't, sometimes you end up with the wrong category. So always start in the center. So this is the center right here where the 2 overlap. Start there first. So all you have to do is compare those 2 names. They tell you what goes in that spot. So it's 9th graders and students who like hamburgers. So these are the 9th graders. So this 600 represents 9th graders who like hamburgers. Okay, once you've got that figured out, then that makes it easy over here. If this is the 9th grade circle on the left, then the 700 must be the people who are 9th graders, but they're not the ones that like hamburgers because we've already got that on the other circle. They must be the 9th graders who like pizza. And then the one on the right, well, we already know they like hamburgers, the 450, because that's in the hamburger circle. Well, this must be the 10th graders, because the other circle is the 9th graders. So this is the 10th graders who like hamburgers. So who's on the outside? That would be the 10th graders who like pizza. So if you do it right, you should end up with 2 labels for every category. So you should have 2 ninth grade, you should have 2 hamburgers, 2 pizzas, and 2 10th grade. So there we go. We've labeled them all, but always start in the center. I cannot stress that enough. Start here first. Do this label first. We'll do another lesson where we'll be doing a lot with this overlapping Venn diagram, and it's easiest if you do the very center first. Okay, tree diagram. TB can be tested in a variety of ways, including a skin test. If a person has tuberculosis antibodies, then they are considered to have TB. Below is a tree diagram representing data based on 1,000 people who have been given a skin test for tuberculosis. So we're going to answer these questions down here. Let me scroll this down. So how many people were tested? Well, they told us in the directions that there were 1,000. Okay. How many tested positive? Okay, so we need to come back up here and look at our diagram and figure out where the testing positive people are. So right here says tested positive for TB. That was 361. And these guys tested positive down here, even though they didn't have TB. That's 62. So you're going to have 361 plus 62, so that's going to be 423. So what percent is that? Well, that's, or probability, that's 423 out of the 1,000 who were tested. So that's 42.3%. Okay. Next question. How many are false positives? So a false positive means that you don't have TB, but the test said you did, and that's this category right here. Tested positive, not TB. So there were 62 people who were false positives. What percent is that? Well, that's 62 out of 1,000. So 6.2%. Okay, in this situation, explain the consequence of the errors. Name one more observation that you've noticed. So there's lots of things you could put here. If testing positive when you don't have TB, that could be bad if you went ahead and did a treatment that you didn't need. So typically, if you're having some kind of medical testing done, you usually always get a second opinion. So that would be pretty good to get. If you tested positive in any scenario, you would want to make sure that you really had whatever they said you had. Even sometimes if you test negative, even if that's what you want to have happen, you might want to get a second test because they can have false negatives as well as false positives. So in this picture right here, there are 19 people who tested negative. And so if they don't, even though they had TB, so if they don't go get another test, then they're going to miss out on treatment, which is a bad thing, right? Okay, so that's just kind of a quick review of Venn diagrams, tree diagrams. Last question is really easy. You could just answer it, but they just kind of want you to draw a tree diagram just to show the possibilities. It says summer's here and the ice cream truck is in town. The truck offers 3 flavors of ice cream, vanilla, chocolate, and strawberry. The topping choices are walnut sprinkles and chocolate fudge and cookie crumbs. Zoe only has enough money for 1 scoop with 1 topping. How many choices does she have? So basically, she has to pick a scoop of ice cream. So she has to get 1 scoop. So she could pick her vanilla, chocolate, or strawberry, right? And then after she does that, you have how many choices of toppings? So let's see. We have walnuts, sprinkles, chocolate fudge, which is one combination, even though it's on a separate line. So chocolate fudge and cookie crumbs. So we've got 4 choices for toppings. So once she picks one, she's got 4 choices for toppings. So that would mean she would have 12 combinations that she could create with her restrictions. Okay.